In this short video, we look at how we can use integration as a technique when we're looking at designing a superbowl. Okay, there's the question, and what we've got to do is we're looking at the volume of a shape. Now, if we just straight away write in the fact that the volume is equal to pi times the integral. Now, if we read the question and think about what's happening, and perhaps even draw a picture, then it's y equals x minus a squared, which is a parabola, and the vertex of the parabola is at A. So it's this curve is being rotated. So we're going to rotate this little part of the curve, and we're going to rotate it around the y-axis so that it gives us a superbowl that looks something like this. So it's going to go to negative A. Oops-a-daisy. Rub that out. It's going to go to negative A, and it's going to be like that. So it's a kind of flat soup dish, and you know from the lecture that the volume is equal to pi times the integral between a and b of x squared dy. Okay, so we're told that y equals x minus a squared. Now the question is in separate parts. First up, you need to look for the volume when the base is 6. But let's actually just do the second part first, because then we're going to have a general volume function. And we're told that it's going to be the integral between 0 and 4, because the top of it is 4. But we need to find x squared. So let's go over to here. Let's isolate x and then find x squared. So if we square root both sides, then add a to each side, and then square each side, we have an expression for x squared. And so it's x squared is now that. Okay, we could put it in there as that, root y plus a squared dy, but we can't integrate it as it stands, not in this course anyway, so we need to multiply it out. So if we multiply it out, it would be y plus 2a root y plus a squared, and that we can integrate with respect to y. Don't forget, we've got a pi out the front, so we've got a pi out the front there. Now let's do the integration. We'll leave the pi out the front, so it would be y squared over 2 plus, now root y, if you remember, is y to the half, and if we integrate that, it would be y to the 3 over 2 over 3 over 2, which means it's the same as 2 over 3, but we need it to be multiplied by 2. So it would be 4a over 3 y to the power of 3 over 2 plus the integral of a squared, which would be a squared y. And we've got to do all of that between 4 and 0. Okay, I think we can tidy that up. Let's leave the pi out here, but let's put in 4. So we've got 16 over 2, that's 8. And then we're going to put in 4 instead of y to the 3 over 2. Y to the 3 over 2 is going to be 8. Then 4 times 8 would be 32 over 3 plus, now we're just going to put in y as 4, so it would be 4a squared. So that's a general function for our velocity. And, oops-a-daisy, I've lost my a. and there. So now let's go back and use that to find the answer to part A. Part A says use calculus to find the volume of one of these bowls. Well, we found that V is equal to pi times 8 plus 32a over 3 plus 4a squared. We've found the expression, and then we need to find that if the diameter is 6 centimetres. So if the diameter is 6 centimetres, then the radius is going to come out to 3 on either side, so A must be 3. So what we have to do now is find V when A equals 3. So we put that into there. V is equal to pi times 8 plus 32 times 3 over 3 plus 4 times 3 squared, which is equal to, to put in the brackets, is equal to 76. So it's 76 pi. And if we were to look that up on our calculators, we would actually find that it's something like 238 something or other. So that must be in millilitres, which makes sense for a soup bowl. Part C says calculate the diameter of the base of one of these bowls if it holds 500 mil. So that means now our volume equals 500, and we're going to make that equal to pi times 8 plus 32a over 3 plus 4a squared, which is almost a quadratic. If we rearrange it, then we can make it into a quadratic and make it equal to 0. So we'd have 4a squared plus 32 over 3a plus 8 minus, if we've divided both sides by pi, then there's where the pi under 500 comes from, and that's equal to 0. Then we can use the quadratic formula to find that A equals 4.957, and this would be in centimetres. Now that is the radius of the bowl, it's certainly not the diameter of the bowl. So the diameter of the bowl would be 9.91 centimetres, or 991-ish millimetres. No, millimetres. Yeah, millimetres, because it's a length.